Hello, folks. Welcome to Chapter 8, Day 5. We are continuing our study of confidence intervals with sample proportions. And we are actually going to be practicing constructing one just with the context and going for it, but learning about a structure that we're going to use to do that. So today's context is how much of the Earth is covered by water, which is a stat that you guys can just Google search and find the answer to, but we're actually going to, use a random sampling technique to figure that out. So in a video that you will see linked in the Schoology page, there's a video of me collecting a random sample of geographic locations on Earth using random.org. I'll have a link to the tool if you want to conduct your own sample. But in that video, I sampled 50 locations, and 35 of them were water locations. So the proportion of our sample that was water, 35 out of 50, which is 0.70. And now in number 3, we're actually going to be working through the structure for constructing a confidence interval in a way that is clear and concise, but yet warrants full credit if you're to take the AP test or complete a free response question. So we're going to call the structure state, plan, do, conclude. So you're going to state what we're interested in. We're going to make sure the plan for the method works. We're going to do the method, and then we're going to conclude the method. So the parameter of interest in this problem is the true proportion of Earth covered by water. And the confidence level with which we're going to do this is 95%. In the plan portion, you want to identify the appropriate inference method and check the conditions. So the name of the procedure, we've never named these before, but the name is extremely creative. It's a one sample Z interval for P. Basically one sample because I took one sample, Z interval because we use Z scores, and then P because we're working with proportions. So pretty straightforward. We will need to know those names. To check the conditions, we need to check the random condition, which we took random samples. Which safe to assume that is true. 2, the 10% condition. So we need to check if 50 is less than 1/10 of all locations on Earth, which I like to think that there's more than 500 places you can be on Earth at a given time. So that checks out. And then the third condition is the large counts condition, which we're going to do right here. So we had 50 times 0.7, that's greater than or equal to 10, and 50 times 0.3, that's greater than or equal to 10. And we get 35, and we get 15. So those both check out, and that is the large counts condition, which I like to abbreviate as LCC. So all 3 conditions have been met, so we can continue with our procedure here. The general formula for a confidence interval is point estimate, or PE, plus or minus the margin of error, or MOE, if you want to abbreviate. The specific formula, I'm going to write in black. So the point estimate is P hat, plus or minus the margin of error is our Z star, which is our critical value, multiplied by our standard error, which is P hat times 1 minus P hat over N. And then we can plug in the numbers, which I'm going to write in red. So our point estimate is 0.70 plus or minus Z star for a 95% confidence interval, if you refer back to the previous lesson, is 1.96. And then our values here, 0.70 times 0.3 over 50. So now we can calculate this. 0.7 times 0.3 divided by 50 square root 1.6. So our interval is going to be 0.7 plus or minus 0.127, which gives us an interval from 0.573 to 0.827. So to interpret this, we're going to say we are 95% confident, because that's the confidence level, that the interval from 0.573 to 0.827 will capture the true proportion of Earth covered by water. So remember, our interpretation needs to contain the confidence level, the endpoints of our interval. It needs to state the parameter that we are interested in, and it needs to contain context, which our conclusion has there. You might be wondering what's the actual percentage covered by water. I'm just going to Google it real quick. Earth. The true answer, if you Google search it, is 71%. So our interval did capture that true proportion that we were looking for. So that's the four-step process, which is what we call that. So in your notes, the four-step process is state, plan, do, conclude, with each of the things that needs to be included there. This is going to be the structure we always use for a confidence interval, so have it memorized. We're going to do this enough that you will memorize it. And then in terms of choosing a sample size, this is going to come up in sometimes test questions, sometimes AP questions. It will be on the check your understanding. But basically for the margin of error, if you're trying to figure out and we're going to plug in values for the rest. So you can choose your margin of error, your Z star, you have your proportion given, and we're going to solve for N, basically, is the idea. And we're always going to round up because it gives us a more conservative, it gives us a wider confidence interval, so it's more safe, I guess. If you don't know what p hat is, we're going to use 0.5 because that is the largest proportion you can get. That makes this number the biggest when you multiply those two, which gives us the biggest possible interval, which is a conservative method. You don't want to guess on the proportion and make your interval too small. And you'll see what this process looks like in the check your understanding. So at this point, all right, so for the check your understanding, a company has received complaints about its customer service. The managers intend to hire a consultant to carry out a survey of customers. Before contacting the consultant, the company president wants some idea of the sample size that she will be required to pay for. One value of interest is the proportion of P of customers who are satisfied with the company's customer service. She decides that she wants the estimate to be within 3 percentage points at 95% confidence level. So number one says, using a conservative estimate for P hat, how large of a sample is needed? So this is referring to learning target number 2, talking about choosing a sample size. So this is the formula that we're going to use. So the margin of error that's desired is 3%. We're looking at a 95% confidence level. So our Z star is 1.96. And then since we don't know what P hat is, the most conservative estimate is 0.5 for each. And then we can put that over N. And then this is just an algebraic equation we're going to solve. When you solve that, we're going to get N is equal to 1067.11, which 1067 When we're doing confidence intervals, we want to round up because it's a more conservative estimate. It makes it just a little bit wider. So we have n equals 1,068 is our answer for part A. We can't round down, or we can't have the 0.11 because you can't have partial number of people. And rounding down makes your confidence interval smaller. So number 2 says, in the company's prior year survey, 80% of customers surveyed said that they were satisfied. Using this value as a guess for p-hat, find the sample size needed for a margin of error of at most 3% with 95% confidence. How does this compare with the required sample size for question 1? So again, 3% error, 95% confidence level, so that's our z-star. But now, instead of 0.5 as our proportion for p-hat, it's 0.8 and 0.2 because it's 1 minus p. And then we have over n. And when we solve that using our algebra, we get n equals 682.95, which again, we have to round up. So n equals 683. And you can tell that the sample size has decreased in comparison with the first one. For both of these questions, I just want to urge you that when you're entering it, you don't round your answers early, you round them at the very, very end. So if you're using a graphing calculator, keep those full values in the calculator as you're working with it. Number 3 says, what if the company president demands 99% confidence instead of 95% confidence? Would this require a smaller or larger sample size? Assuming everything else remains the same. Explain your answer. So we have 0.03. We're looking at 95% confidence, and we're going to leave everything else the same. So we have 0.8, 0.2 over. And then when you solve that, we get n equals 1,179.7, which will round to 1,180. And clearly this would require a larger sample size. The reason why it needs a larger sample size is because if you're increasing the confidence level versus the 95% confidence, more people allows your range to shrink, and you get to hone in on that true value of P. So that is the Check Your Understanding for Chapter 8, Day 5. If you have any questions, feel free to reach out.